All right, students, welcome to our lab on glaciers. They're probably one of the more weird subjects we'll be going over because you just don't normally see them. After all, they're giant chunks of ice. So come with me, it's time to get cold. Ice cold. So, what is a glacier? It's a large mass of ice and snow that moves under its own weight. So basically, don't think ice cube, think river. A massive, giant river of ice flowing down the countryside, smushing everything in its way, grinding it to dust. Nothing we can do remotely comes close to the power of a glacier to reshape the land. And glaciers are formed when snow doesn't entirely melt every year. So as the snow piles up, it gets squished and forms ice. Now, there are two types of glaciers. First, we have valley glaciers. Um, as the name implies, they form at high elevations on the side of mountains in valleys, hence the name. The neat thing about them is because they form at high elevations, they can form anywhere in the world where you have a relatively high mountain. Even in the tropics, as long as you get high enough, you get cold enough, and you can form a glacier. I used to work in Great Basin National Park, and it's in Nevada, which is a fairly warm state. However, we had such a huge mountain, almost 14,000 feet high, we had a glacier on it, albeit a very small glacier, but we had a glacier. And that was a valley glacier. Then there are continental glaciers. These are masses of ice that cover a huge area. You go up there, you see, oh my, I'm totally surrounded by ice. That's a continental glacier. So massive slabs of ice covering hundreds of miles, and these are mainly found in Greenland and Antarctica. So you don't see them very much nowadays. But in the past, there were much, much more continental glaciers. That was during the last ice age, when the climate cools and continental glaciers advance. That's an ice age. The last one was about 12,000 years ago. So right around humans, we're starting to get our human thing on. Um, that was the last ice age. So you got things like woolly mammoths, ground sloths, saber-toothed cats, etc. All were in the last ice age. And as you can see, there is way more ice on the world um, than there was is now. Now, pretty much this area is covered with ice. But the last ice age, all of this was covered with ice. And if you note, we are right here on that star. So we're 12,000 years ago, we would have been right next to the last ice age. And it had a profound impact on our state. So if you take a look here, this red line is the last ice sheet. Okay, the furthest advance of the last ice age. And you can see we are here. And I said it has a great impact on many things. The greatest, I would say, is, well, it's why East River is so depressingly flat. Basically, the glaciers came in and bulldozed everything down so it's flat as a pancake and super boring to drive through. The second thing is the river. The Missouri River here. Because if you note, the Missouri River is almost on the exact edge of the last ice sheet. And that should make a lot of sense. So, in fact, the Missouri, at least in this area, owes its formation to the to the Ice Age and the glacier. Basically, what happened was all these rivers would flow and they'd run smack into the slab of ice. And well, you can't have a river flowing through a mile high thick sheet of ice. Therefore, instead of flowing through it, it would flow along the edge down to the sea. Whereas in East River, as the glacier retreated, it formed valleys, uh, and that's where the rivers flowed. So you can basically, this was the original where the ice sheet was, and as it retreated to here, which formed a river, and here, and so on. So pretty much the whole eastern part of South Dakota, that's glacier territory. So I would like you to think for a couple minutes. Think, imagine if you could travel back in time 12,000 years to where Mission is. What would it have been like living next to a continental glacier, that huge slab of ice? Now, one of the things about glaciers is they do two things. First off, they move rock. Imagine gigantic bulldozers just shoving rock in front of it. But as they move, they also break up rock as well. They grind it into dust and just shatter things with their huge weight. So this is how glaciers break rock. There are several methods. First is plucking. No, we aren't talking about the pheasants that you got when you're out hunting. Plucking is when water flows around rock. As it moves, there's a lot of friction, which can cause the ice to partially melt. And however, it's right next to ice, and so it freezes again, and then it basically glues the rock to the bottom of the glacier and rips it right out of the ground. Um, okay. Then there's abrasion. Again, we've got lots of grinding going on. So there is tons of sand on the bottom of the glacier, and it acts like sandpaper. Just wears away the rock. So if you see some place, like if you go out to Yosemite in California, you'll see lots of rocks like this, which have almost a mirror finish because of the polishing action of all that sand and grit in the bottom of a glacier. And sometimes, if you get bigger rocks that get lodged in the bottom of the glacier, they just drag it along, and we call those striations. These nice grooves caused by the bottom of a glacier.